Alrighty, good morning or good afternoon, ladies and gentlemen. Today we're going to cover 4.3. So if you remember yesterday when I covered the other day when I covered 4.2, I went over something called slope-intercept form. So as a quick recap, we had before, we had this y equals mx plus b, and we called this slope-intercept form. And why we named it slope-intercept form? Well, the that m variable that we have multiplying our x, was equal to our slope, which we said was our rise over run. So basically a measure of how steep our line is, either going up or down. And then our b was this thing called the y-intercept. Now, I used a football analogy, but this was where our line crossed the y-axis. Today, I'm going to show you a different form or a rearrangement of this equation. It's very common in higher levels of math because it is good for finding certain things. So in this section, we have something called standard form. And standard form looks like ax plus by equals c. And just to keep in mind, a, b, and c will be numbers. One thing I want you to note, these are not physical quantities. And what I mean by a physical quantity is like slope or y-intercept. So some students find this tricky because a, b, and c are just numbers and they don't represent anything. Whereas before, when we were talking about our y equals mx plus b form, the m referred to how steep our line was, our b was our y-intercept, and the x and y were where I am either vertically or horizontally, depending if I'm talking about a y or an x. So to find this equation is good for finding very specific points. Specifically, it's good for finding our intercepts. Now, I've talked about a y-intercept, which is where our line crossed the y-axis, but now we're also going to introduce this x-intercept, and this is where the line crosses the x-axis. So same idea, the line crosses something, and we call it the x-intercept because it crosses the x-axis, and the y-intercept because it crosses the y-axis. So important things to note is that for the y-intercept, we had the point 0, comma, y. For the x-intercept, it's now the opposite. I have an x value and my y is equal to 0. So kind of the takeaway or the thing that you should keep in the back of your head is that for our y-intercept, x is 0, and for the x-intercept, y is 0. So I'm going to jump over to the side here. I'm going to graph the equation that they have in the example, but I'm going to show you how I would go about solving it. So first up, they say if you want to graph this equation, first up, there's no slope. So I can't use my staircase method. I can't find my y-intercept directly. This doesn't give me information. So my strategy is going to be a table of values. But I want to pick specific points. So I'm going to start by making my table of values here. And I'm going to pick two values. I'm going to look for the x-intercept and the y-intercept. And this is where x is equal to 0, and this is where y is equal to 0. So the 2 points I want to always start with, I'm going to start with picking x is equal to 0 and solving for y, and picking 0 for y and solving for x, because this will give me 2 points on my graph. And you'll see why I want to do this in a second. So let's start with x equals 0, and I'll plug it into the equation 3x plus 2y equals 6. So if I plug in x is equal to 0, remember every time I see an x, I replace it with a 0, so I have 3 times 0 plus 2y is equal to 6. Now, this is where it's going to look much simpler, because 3x plus 2y equals 6 is a bit of a daunting equation. But notice if I pick 0, 3 times 0, well, this is just equal to 0. It cancels out, and I can basically ignore it. I can remove it entirely, so my equation simplifies down to 2y is equal to 6. And now this is a much easier question to solve, so if I was to solve 2y is equal to 6, I would divide both my left and my right side by 2. This cancels out to give me 1, and I end up with y is equal to 3. So this is my value here, so I'm going to move it over and put it here. Remember, with our table of values, this represents our ordered pair, which I'll be plotting. For the second point here, now I have y is equal to 0. So I have the equation 3x plus 2y is equal to 6. Oops, sorry, let me clean that up. So I'm going to have 3x plus 2, and then I replace the y with a 0. So 2 times 0 equals 6. Now this part goes away. Just like before, anything times 0 is equal to 0. So 2 times 0 is equal to 0. And then if I try to add 0 to something, it's not going to matter. So basically, I get rid of that entire second term. So I end up with the equation 3x is equal to 6. Divide both sides by 3. And then I end up with x is equal to 2. So I have this value here. So currently, I can actually plot these 2 points. Now remember, you only ever need 2 points to plot a line. So if I was to plot these two, I have 0, 3, and then 2, 0. The other nice thing about these kind of standard form graphs is that you know your plotted points are always going to end up along your 2 axes. So at least 2 of your points will end up here. So it's nice to have kind of this like shorter area to look at. I'm going to go one step further. Remember, we want that third point to represent sort of a check for ourselves. Because maybe I made a mistake on one of these and I want to double check my work. Because currently my line will go something like this, but I want to be doubly sure. So to do this, I'm going to pick the number 4. I can pick any value for x. Keep in mind, I can't pick 0 or 2 because those are already taken, but I can pick negative numbers, but let's just pick 4. So I have x is equal to 4, and the equation is 3 times x plus 2y is equal to 6. So this is going to be a little bit harder to solve, so I have 3 times 4 plus 2y is equal to 6. So 3 times 4 gives me 12 plus 2y is equal to 6. So currently I have this, trying to solve for it. What I would do, I'd take away the 12 from both sides first. This cancels out and gives me a big old 0 plus, so on this side, I can drop the plus because there's nothing else. 6 minus 12, I have to be careful, so this is going to be minus 6. So then I have 2y equals negative 6. Divide both sides by 2, and I get y is equal to negative 3. So I'll put negative 3 here. This is my third point to plot, so I'm finding 4 on my x and negative 3 on my y and plotting my point. And I notice that these form a straight line, so I know that all my points are currently correct. Either that or I've made a mistake on all 3 of them, which is usually fairly unlikely, so you can feel pretty confident if your 3 points line up that you're doing something right. So last step is to connect our lines and add arrows onto both ends. Just something to highlight though, this here, if you remember from our slope, this is a negative slope line. It goes down and to the right. However, in our initial equation, all of our numbers were positive. So this is one of the things to keep in mind that's tricky about standard form is, like I said before, that 3, that 2, and that 6 tell us absolutely nothing about which direction the line is going in and where we can find our slope. It happens that our 3 and our 2 kind of mirror these, but that's just coincidence in how the numbers and the math worked out. Additionally, I could have picked any number that I wanted to, so I could have picked 1 for x. The problem with that is that 1 for x would give me this value here, which is probably I would say like 1 and 2 over 3, something along those lines. So it's hard to tell. It might be 1.5. I picked 4 because I noticed that if my line worked, it should end up kind of at this nice point. So for this point here, be strategic. So look for the ones that makes your math a little bit easier. So what I mean by that is I noticed that, well, I get 12, and then 6 and 12 make 6, and then everything is divisible by 2 in this case. So I'm making things that are nicely divisible. If you don't end up finding this, that's okay. If you just get a third point and it's in that same general vicinity and you estimate it and you go, okay, it looks like it's in the same area, I'm good, that's fine too. But that third point is really important for checking your work. And you can see for them, they actually picked -2 and they went up to 6, which would have been off the graph for me. It would have been somewhere up here, or even further, it would have been up here. So also keep in mind the sort of this area that you have in your graph. If you're running out of space on one side, go to the other one. All right, now we're going to get into what I like to call special cases. And part of this has to do with what equations look like. So this is a bit of a divergent from your notes. I'll put that up in a second. But let's think about, is the following a linear equation? So we're trying to answer the question. So for number 1, I have y is equal to 2 over 3x plus 4. I'll give you a moment to think about it. You can pause the video, think about it. Okay, so for this one, this is in our y equals mx plus b form. Our m is equal, or we have y equals mx plus b. This is one way to think about it. So our m is our 2 over 3, and our b is our 4. So in this case, yes, it is. For number 2, I could have 2x plus 2y is equal to 10. Think about it for a moment. And again, for this one, the answer is yes. And this is from our newer equation, ax plus by equals c. These should work out. These should give us lines. Okay, what about, this is where we start to get a little bit trickier. Y is equal to 2x. Pause it for a second, think about it. So this is one of our tricky things. I'll say yes to start and explain why. Now, some of you might be going, oh wait, it doesn't look the same. It doesn't have that y equals mx plus b. The problem with this is that we actually do have it in y equals mx plus b form. There's a part that we leave out. There is an invisible 0 here. So in this case, our b is equal to 0, which means that if I was to graph this, it's going to pass through my origin. Basically, it's going to pass through the point 0, 0. So first, special case of our lines. Next up, how about if we have y is equal to x? Think about it for a second, pause the video. Okay, so for this one, again, we might think no, because it doesn't have either of those forms. It looks sort of like y equals mx plus b, except the m and the b are both missing. But in this case, we already know from the previous example that this could be 0, and there is in fact a number here. It's 1. So this is the equation where m is equal to 1 and b is equal to 0. So this line goes through the equation, or goes through the origin, just like our last one, whoops. But it also has a slope of 1. So it basically goes 1 through every whole number point. So it would go through 1, 1. Up here we would have 2, 2. Basically, slope equals 1, and it passes through the origin. All right, so the last two I want to show you is, and these ones will look really suspicious. I have y is equal to 5, and I'll do the other one together. X is equal to -3. So think about these for a second, pause the video. All right, so for these ones, it's even harder to think about and think about them in terms of that form. For this one, I have y is equal to mx plus b, but there's no x. This whole thing here is equal to 0. This is only true if our slope is equal to 0. Basically, what we have here is there's no slope. Or another way to put it, it doesn't matter what my x value is, my y value will just be 5. It's literally the statement y equals 5. So if, sorry about that, if I have, and I'll go up by 2, or I'll go up 1, sorry, I'll go up 2, 4, 6, 8, so 5 will be right here. Basically, for all values of x, y will be 5. So this is one of the special cases that it gives it to us, is our our line will look like this. Y equals 5 is a horizontal line. Now, it's a little bit harder to show with question 6, but the answer to this one also is yes. And it is for 5 as well. With x equals -3, we run into the opposite case where now it doesn't matter what y is, x is always going to be -3. So I have -3 here on my x-axis. I find that and I draw my vertical line. So now my y can be anything and my x is limited to that value. So x equals -3 makes a vertical line. Now, the issue with this is I can't put this into y equals mx plus b form, because if I think about the slope, so if I think about m is equal to rise over run, how much do I rise compared to how much do I run? Well, if I think about this, I go up any amount and I'm going to run 0. So I'm going to have rise over 0. I can't divide by 0. This is technically, we say in math, undefined. But another way you can think of it is that the slope is infinite. It's a straight up and down line. So this works in standard form, but it's one of the cases that we can't graph it in slope-intercept form, because I can't just say y is equal to infinity x plus something. Like it doesn't make sense. I can't plug that into a math equation. So the two special cases that they talk about is for vertical and horizontal lines. So they have a little nice summary down here. You can make a table of values, but for example, the table of values of x is equal to -3 looks something like this. You just pick -3 for your left-hand side. There's nothing to calculate for your y's. You just plug in random numbers. I find it's easier to find -3 on my x. So I find this point here, and then I just go up and down. Now, the tricky part for this is that we generally think y is up and down and x is left and right or horizontal, and yet when we draw the lines y equals 4 or x equals -3, my line is the opposite. The way I can think about, or the way I like to think about this is for y equals 4, it doesn't touch the x-axis. It only deals with the y-axis. So if your equation has y in it, but no x, think about it only dealing with the y-axis. If it says x only, then it only deals with the x-axis. And then if it has both, like we've previously had, then it's going to touch both of them. Now there's two exceptions to this rule, which are down here, where I'll leave that to you to try out. And those are the cases x equals 0 and y equals 0. In any case, I want to keep this video a little bit short. Practice work, I might go over some of these if people are asking enough questions, but mild, try 2 every second one, so just like A, C, E, G, I. These are our left-hand columns. We're basically just graphing in standard form. And then for 3, do all of them. The reason being is that the left-hand column is our x equals a number, and then our right-hand column is y equals a number. So remember, for say like x equals 3, we should have vertical lines for all of these graphs and then horizontal lines for all of these graphs. So just keep that in mind. These ones, for number 4, it's our medium question. These ones are asking you to find the point. So for example, to show you for B, they want you to find -2 on the x. So I'm going to find -2 on the x and then find the value for y. So, it's at 0, so I'm going to plug in 0. 1, 2, 3, 4, 5, 6. It's going to be right here. So this is at the value 2. I'm basically pulling the y values off to put over here. So then when x is positive 6, which is over here, I notice that the y value is down here. So it would be -4. So you're just filling those ones out. It shouldn't be too hard. And then number 5, these are definitely our spicy ones. You're basically given an equation. So you would have y is equal to -1/3x minus 4, sorry. So you're given this equation. So that equation will be something like that. Or to do it a little bit more precisely, 1, 2, 3, 4. I'm just doing a quick reverse staircase method. Your line is going to look like that. This one wants you to plot a second line that passes through the point indicated. So the point indicated here is 0, 2. So that is the point up here. So I need to make a line here that's parallel to this one. And I don't want to guess, I want to do it exactly. So think about what it means for two lines to be parallel. As a hint, it has something to do with either the slope or the y-intercept. And notice how all of these are in our slope-intercept form. So think about those. I don't want to give away the answers too early, and don't just follow this. This line is graphed correctly. This one is likely not because I just drew it off the top of my head. But think about what it means for two lines to be parallel. In any case, that's all I have for you today. Thank you very much for listening. Stay safe. Take care. Stay safe. Have a good one. Bye.